Hello, everyone. Welcome to 26.1 AI Podcast. Today we have with us Matthew Rockland and Hugo Bound-Anderson of the Coiled team. And just to highlight for supporting startups, if you do anything in your enterprise that handles data, talk to them.
Welcome, Matt and Hugo.
Welcome, guys. It's Brian Ray here and Don Shu, and we're doing our first interview with two people simultaneously. So, let's start with you, Matt, and then tell us about how you met Hugo.
Yeah. Hi, everyone. My name is Matt. I don't actually remember where I met Hugo. Probably at some PyData conference. I've worked in the PyData space for a long time. I then sort of worked on and maintained Dask for parallel computing. And then we sort of made this company Coiled. Hugo, where did we meet each other? Can you help me out?
I can. I remember where we met because I was working at Data Camp at the time. We were doing online data science education and working on a collaboration with what was then Continuum Analytics, where you were at the time. And I wanted to do a Dask course, and I sent you an email. We were both going to be at ODSC Boston. And we sat down, I showed you the platform, and we had a good chat. And I remember having dinner with you, and I think we've discussed this, and you don't recall this evening, but I had dinner with you and Andy Muller, who's as you all may know, a core contributor and co-maintainer of Scikit-learn. I just sat there feeling like listening to you two riff about how to do distributed compute for machine learning in the PyData stack down on the waterfront in Boston, and it was an incredible meal, a real experience for me that you don't remember at all. But all jokes aside, that's how we initially met. But we then made a course together on Dask at Data Camp, and hung out at conferences and went out for drinks and dinner and that type of stuff, and always enjoyed chatting. And then one thing led to another. This year, you were securing funding for a company that at that point you wanted to name Snake Oil, which I love but pulled you back from. And we ended up starting to build Coiled together, where we are now.
Matt, Hugo, I've been reading some of your writing, and both of you are wonderful writers. I'd like to highlight that. But maybe also share how that came about. Is that your academic backgrounds? Both of you are PhDs.
I love this comment because you tell him, Matt.
So Hugo and I have extremely different writing styles, and we're both relatively opinionated about those writing styles. Mm-hmm. I am maybe more concise, while Hugo's maybe a bit more floral, maybe would be a good term.
Verbose. Prolix.
Verbose.
Yeah.
And so we argue a ton about our collective style, the style of Coiled. And I think, as we all know, sort of constrained creativity ends up hopefully producing something that's better than otherwise. So between us, hopefully we're both concise and exciting. That's, I think, the goal. Go ahead.
Something I value in Matt's writing, what I'm learning about is precision as well. I'll describe the same thing in 3 different ways to try to get the message across, whereas Matt will be very precise, laser precision in order to hit the nail on the head immediately, which I think, particularly in I suppose what we call the attention economy now, is even more important.
So, Matt, your title on the Coiled website is Task Scheduler Extraordinaire. Any comments on that?
Yeah, we were trying to find sort of fun, pithy descriptions of ourselves. So it's a joke because I write Dask, which is a task scheduler under the hood. That's like the thing that Dask does. It runs code in parallel with the task scheduling framework. It's maybe like the next iteration of like a MapReduce kind of thing. Beyond MapReduce, there's task schedulers. But now, as someone running a company, I mostly just handle calendar events and try to connect people and do a lot of task scheduling in sort of meat space or in human space. And so I think a lot about scheduling and making sure things get done. And that's, I sort of changed from being a programmer to a human or organization programmer.
So you're a clock watcher, not a guild watcher, but a clock watcher. So, and Hugo, your title is head of data science evangelism and marketing, and I love that title. But what does that mean? What does that do?
It's a mouthful. There's a lot to unpack in there. I think the way I like to think about it is that we're building a company around an open source technology and trying to connect the enterprise organizations, researchers with open source technology and the open source community. So as a marketer, as the head of marketing, I want to get as many people as possible interested in the product, Coiled. As the head of evangelism, I want to get as many people interested in open source technology as possible. And I think combining both of those, I joke that I'm kind of like, it's a horrible thing to say actually, because I joke that I'm kind of like Two-Face in Batman, but I'm the good version, right? And the way I think about it is that there are certain trade-offs in wearing both these hats, but ideally, all of us are working to find a way that open source and the enterprise and organizations can work together as well as possible. And I'm kind of on the communication, evangelism, and marketing side of that.
This is a great tee up for a question I've been wanting to ask in preparation for this episode. Dennis Ritchie once said the most important part of Bell Labs was the break room, because there serendipitous conversations happened and some real breakthroughs came through from that. I noticed in reading both of your writing, both of you describe these conversations you've had with people in open source and how that's influenced your career paths and your projects. Care to highlight some of those conversations? Like, I saw a lot of input from Andy Mueller, for example. Matt?
Sure. I think that's an interesting question. I would say good open source. So there's this idea of like Bell Labs was very creative, right? They made a bunch of game-changing things that weren't sort of known before. I think the work that I have done is actually quite different. I think a lot of the scientific Python space came out of a lot of pressure from problems. We're just talking to people. It was very clear what had to be done. And then you needed to make something that was well-engineered and ergonomic enough to fit those needs. I think that we've actually been relatively uncreative in a way that Bell Labs has been creative. I think that is actually maybe some of the strength of the sort of PyData SciPy space in how, again, not necessarily spontaneous or creative we've been, but in how sensitive we've been or in how receptive we've been to a lot of the needs of sort of everyday scientists, which eventually translate into the needs of data scientists. So I might sort of push back a little bit on the premise of the question.
And I'll also add that to see that in kind of its almost primordial form, all you need to do is go to Austin in summer. Well, not now, of course, but given COVID, but go to the SciPy conference and see how a lot of what has happened and what is happening now in the developed community is from really urgent scientific research needs. And I think IPython back in the day is an incredible example. Matplotlib. I remember speaking once with Skipper Siebold about why he developed stats models, or Wes McKinney about why he developed pandas, and it arose out of like serious pressing needs for this type of tooling in the space.
Yeah, good answer. That's a nice contrast that you make about how Bell Labs was this sort of very open space where they were finding kind of solutions to problems that didn't even exist yet, and where in open source you're responding very directly to the community need. That's great.
And the community relationships are very important. Mentorships. I mean, I mentioned Travis Oliphant, and he's someone who, for Travis, I think the PyData space is also an extended family, which is incredibly important. And the idea of community and mentorship is incredibly important there also. And once again, you go to the conferences and you get this feel.
Does Dask compete with Spark? Do you believe?
That's like a complete. It's a very interesting conversation twist. To answer the question, though, yes, Dask competes with Spark and not. They handle some overlapping use cases, like ETL for data frames, and they also diverge in what they handle. So, Spark is going to be a better, SQL database kinds of system. Dask does that a bit, but it's not a proper SQL system. But Dask will handle a lot more unstructured data better, or do more sort of ad hoc computation better.
And I'll connect that back to the previous conversation. So I know the Spark community and Apache community and other things like that. They have great force, great momentum. What is it? How does an open source project and the mentality around the scientific computing community gel with that? Is it distinctly different? Are they meant to be playing well together, or whatnot?
Yeah, that's you're getting into like a very deep, interesting question there. Like Apache was projects like Spark came out of the needs of lots of sort of large web scale or maybe more advanced companies. They come out of business processing, and Spark handles a lot of the sort of business analytics problems you'd expect to be solved there. They tend to be a bit more monolithic, I would say, those packages. Like Spark does all of the things. You're intended to use just Spark on its own. Maybe you attach to Hive or to some other technologies, but you're sort of just installing Spark. I think a lot of the scientific computing or the PyData packages had a much more federated structure. It was a couple of graduate students in a lab that made IPython, which then eventually turned into Jupyter. There was a few neuroscientists who made scikit-learn, and there was a lot more of a community bazaar feel to that group. There was no money behind any of it. There was really no organization. There was a much more of a coalescing of individuals and groups, and an agreement on standard conventions. And so I think that difference of sort of top-down design for Spark, or the other sort of Apache projects, to I think a slightly different community feel without the presence of money originally, just created a different communal structure, and as a result, a different software architecture.
And I'll just build on that briefly by saying Matt has written a really interesting blog post called A Brief History of Dask that if you're interested in what I'm saying here, you can check out on our blog, coiled.io/blog.
Well, and also there's an article, not to interrupt, but there's also an article on there that do we really need distributed machine learning? That's by you and Andres.
Yeah, exactly. And so, yeah, we're definitely very interested in the community aspects of this. But one of the points that Matt made is that, this Dask came out of, and correct me with any details I'm mistaking, Matt, but out of, people sitting down at the time, including, Peter and Travis and Matt and a whole bunch of people, and thinking about how do we scale the PyData stack? It wasn't how do we necessarily, solve these big data problems, but it also came from the PyData ecosystem. And so there were technical goals, right? One, to harness the power of all the cores of a local workstation in parallel, another to support larger than memory computation. But there was also a social goal, which Matt mentions in this post, which I love. It was to invent nothing. And I quote, Matt wrote, "We wanted to be as familiar as possible to what users already knew in the PyData stack." So for example, if you already write your NumPy code, then you import a Dask array, and most of your code remains the same. On top of that, it's actually, for the most part, running NumPy, but behind the scenes. So your mental model of what's happening is actually what's happening, and you don't have to necessarily solve Java errors when importing.
Matt, maybe remind the listeners how many lines of code you wrote for the first version of Dask.
Yeah, it was a 14 line commit, I think, which was the first Dask task scheduler, which could run interesting programs that then could work with NumPy, could work with pandas, and try to scale them out a little bit to maybe like bring those two things to get your comment and Hugo's comment together. Dask is actually relatively small, right? Something like Spark had to reinvent a lot of code that was in pandas or was in NumPy or was in Tornado or was in some other libraries. And Dask was a question of, well, what's the minimum amount we can add to these existing software packages and this existing software ecosystem to scale out the existing community of packages? It was a different kind of problem to solve rather than sort of a de novo creation of a completely separate software stack.
Is there, I think Guido said once there should be, or maybe this is from Python community, there should be one and only one way to do things. And then I see things like Modin and Arrow and a lot of tools on top of tools today. Are we moving towards one good solid way to do things, or are we moving apart from that?
Yeah, I think even at the time when that was written, that still wasn't true. I think there's always been many ways to do things in Python. and there's also many ways to do things in sort of the PyData or SciPy stack as well. What I think binds us together is common conventions, right? And so there's things like the NumPy API or the Pandas API, which might be shared. Or there's things, like Arrow is trying to build a convention around memory transfer that can be used with Pandas and with Spark and with Rapids and with other projects. And so I think the real cohesion, the one way, is about bridges. It's about these conventions and protocols rather than about libraries. And that's where I think we're seeing a lot of software, a lot of successful software ecosystems being designed around. It's around conventions rather than
And
libraries.
I love that you mentioned the one way to do thing, because one of the places that you're referencing it from, I think, is actually the Zen of Python. And I think what it says, there should be one, and preferably only one, obvious way to do it. And I love that, because it says there should be one obvious way to do it. But then it says preferably only one, because you've got a bunch of ways to do things, right? To do any one thing, but you want one obvious way that you gravitate towards. And I think that's what Matt's speaking to in terms of shared conventions and shared foundations and shared language as well.
And I was there, since we're getting into Python stereotypes a little bit, at PyCon in 2016 when Brian texted David Beasley teasing him that your friend the Gill is going away. How much what the PyData stack and Coiled and Dask is doing is making that assertion that Python is not performant kind of trivial?
I think the GIL has not been a problem in the PyData SciPy stack for many years, right? Most of the code that we write is actually written in C or Fortran or LLVM or CUDA. We just use Python to direct that code, right? When you're calling NumPy or Pandas functions or scikit-learn, you're not actually really calling Python. The GIL is not present there. You can run many scikit-learn functions in parallel in one process and saturate a 40-core machine. So the GIL isn't really a problem in the SciPy space. It is if you're like handling text, but if we're working on numeric data, it's fine. I think what we're seeing, to maybe go a little bit beyond your question, we're actually starting to see the Python data science stack, of which Dask and Coiled are a part, but only a part. We're seeing that stack actually start to beat the more high performance stacks. One example of this is Rapids. Right? Rapids is a GPU accelerated variant of the PyData stack. So they've got GPU accelerated Pandas, GPU accelerated NumPy, GPU accelerated scikit-learn, XGBoost, et cetera. And when you scale those things out with Dask, we're starting to see our sort of community of projects just crush benchmarks. I think NVIDIA published benchmarks on the TPC XBB benchmark, which simulates a sort of data science-y machine learning workload. I think they're trying to simulate a large bank. And I think in that workload, they get something like 20x faster performance with a machine that's maybe like 3 times more expensive. So sort of a 7x cheaper experience. And this is on a benchmark where the previous winners were a variety of companies trying to cobble together hardware and Spark or hardware and Hadoop to try to handle these benchmarks. And they were trying to compete for 10%, 20% wins over each other, and just hammering those things with teams of engineers. The fact that this Python-driven stack walks in and just crushes it to a 20x multiple is showing that it's not that Python can be slow, but the community approach that we've taken of grabbing some CUDA engineers from NVIDIA, some distributed systems engineers from Coiled, some UI experts from the community, Blazing SQL, all these different groups, and throwing them together in this sort of mishmash of software projects that works really well together. That approach is just fundamentally more powerful than a really well-crafted C++ code base.
Well, let's talk a bit about where it runs. Now, I think Don told me you guys are on AWS. Where does the cloud and the hyperscalers come into play with computation and the future of doing solving these hard problems? Are they critical players, or is it does not matter?
Yeah, so there's a few different things we can get into there for a second. So I'm gonna explicitly call out Dask versus Coiled just for a second, because I think you're sort of making that jump. So tools like Dask deploy on a variety of different architectures: Kubernetes, Yarn, Slurm, lots of different things. If you have any software that manages a bunch of machines, Dask can run on that software today. What we've found, though, is that that requires a level of expertise that is relatively rare. There are relatively few organizations, there are very many organizations that have the need to compute on large amounts of data with a large number of computers, but relatively few of those organizations actually have the skill sets to stand up a bunch of machines on AWS or on Azure or on GCP and then manage those in anything resembling human efficiency. They usually sort of start trying, it becomes a pain in the butt, they want to stop doing that. And that's where companies like Coiled can step in, right? We've done that in I don't know how many companies historically before, and we're just productizing that sort of common process. So we provide all of the sort of stuff that you need around Dask to run it in an effective way. Security, managing software, managing teams, getting better telemetry off of everything. And that productization actually increases accessibility quite a bit. You can now be an individual and have the same capability that like Google has, or you can be an individual or a small team and have the same capability that Uber has. And that sort of leveling of the playing field, or that democratization, is what I think really excites me today, and that now these technologies are becoming a lot more accessible to everybody.
And that opens up the world of Dask to a whole new breed of people as well, who don't necessarily aren't able to get into the weeds with all the like DevOpsy and Kubernetes and containerization and all of this stuff. So one way to think about it is we take the DevOps out of getting your clusters up and running via one-click or even zero-click hosted deployments. And I do have to give a shout out to I don't know whether it was you or James who was responsible for something as wonderful, Matt, as pip install Coiled, which allows you to get up and running from wherever you pip install immediately with a Dask cluster.
I tried that. I think it's brilliant, and hats off to you guys on that. But on the note of the future, of like where we're going, I'm going to have two questions, and you can answer them simultaneously. But I always like to ask this. First off, in parallel with Dask, please answer these questions. What one is usually around where you see the AI hype going, and tightly coupled with that oftentimes is what are your fears about where AI hype is going? Do you have any precautionary tales? Do you worry about where people are taking it at all?
Well, Brian, I want to prep you that Hugo gave a talk about is data scientist the most dangerous job of the 21st century?
Well, that's
that is true. I mean, data science is creating a lot of different things in the world. But I'm actually interested in what your definition of AI is, because we can slice that so many ways, and people mean so many different things when they use that term.
When I say AI, I mean machine learning on top of machine learning. That's my definition.
Yeah,
where it's coupled, where there's some sort of stacking of predictions. That's my definition. But I might be wrong. I don't know.
I'll have to admit, I do not understand the definition of machine learning on top of machine learning, so we have to dive into that a little bit.
You should hold Brian's feet to the fire.
So we're talking about predictive analytics, essentially, in this framework.
Yeah, I mean, it's become it was passé when there was an AI winter. Well, there was two of them.
There've been three. So I think they say the fourth one's coming.
Hasn't there?
The AI winter is coming.
Yeah. Well, I just believe when we're talking about AI, in my mind, it has some sort of human in the loop element, and it also may have more than one prediction behaving together for a solution. Versus when I think about machine learning, I think about a model that returns a number or a category. Period. That's my definition. I don't know if I'm right or not on that.
Yeah, I like that. We can talk about machine learning. I think AI probably can. Other people incorporate a variety of different things. People use it relatively liberally. But I think machine learning, like any technology, can be used for great stuff. It can be used for dangerous stuff. I think one of the big challenges is it does stuff really quickly at scale in ways that humans really haven't been able to do before. And it does it a lot of the time without necessarily being able to be diagnosed or looked into. I mean, we've got this whole interpretable AI movement, responsible AI movement and that type of stuff, which I think is really important. But I think if we're increasingly interacting with a lot of different machine learning models out there, it's worth thinking about responsibly. And I think one of the most important questions is how the human fits in the loop. So I'll give one example that we're going to see increasingly. Let me get this right. Machine learning models used in hiring flows in organizations. Okay, so a chief people officer or head of HR or recruitment will be using it to filter resumes and that type of stuff. Now, they need to know about the accuracy of the model, sure, but maybe they need to know about false negative rate and false positive rate as well. So it's how we educate people with respect to what the models are actually doing. Perhaps they really need to know about the type of biases that can happen in recruiting models as well. Mozilla Labs put out a wonderful online game has a great name. It's called Survival of the Best Fit. And you play a CEO going through a recruiting pipeline. Then you've got to speak with VCs. So suddenly you need to automate your recruiting and that type of stuff. And you see how it goes wrong there. So I think there are a lot of dangers, which is part of what the question is about. And I think part of the movement to counter these dangers involves educating the humans who will be in the loop with respect to them, which will be a lot of.
Sorry to interrupt your episode of 26.1 AI podcast. This is part 1 of a 2-part series. We'll see you next week for the remainder of Coiled. Thank you.